Well, hello everyone. We are going to start our first lessons in the second term. In this term, we have two chapters, chapter 3, which is called hydrostatics, and chapter 5, which is called gases laws. Okay. Now we are going to talk about chapter 3, which is called hydrostatics. Okay. I want to tell you a small or a very small introduction. What's meant by fluids? What is meaning by fluids? You have already studied before that any matter may be solid, may be liquid, or may be gas. And to differentiate between solid, liquid, or gas, if I want to tell you that matter X is solid, matter Y is liquid, matter Z is gas, how I can differentiate between them? I can differentiate between them by knowing the intermolecular spaces or the intermolecular distance between the molecules of this matter. For example, if the intermolecular spaces is very small, so this matter is solid. And if the intermolecular spaces between the molecules of this matter is intermediate or medium, I can call it liquid. And if the intermolecular spaces between the molecules of this matter is very large or extremely large, so I can call it gas. So I want to tell you what is the fluid. Fluid, it is any liquid and gas. All of the liquids and all of the gases are called fluids. How I can differentiate between liquids and gases? Well, liquid has a definite shape and definite volume, while gases has indefinite shape and volume. For example, if I put a gas in a container of 3 meter cube volume, so the volume of the gas is 3 meter cube volume. And if I put this gas in a container 6 meter cube volume, so the volume of the gas will be equal 6 meter cube volume. Okay. Any fluid, either I'm talking about liquid or gas, maybe static fluid, which I won't tell you the meaning of static fluid, which is the fluid at rest, not at motion. And the second type of fluid is dynamic fluid. It's any fluid which is at motion. In this chapter, we are going to study static fluid as we have studied in the first term, chapter 4, called dynamic fluid or hydrodynamics, viscosity and flow rate and so on. In this chapter we are going to talk about two of the most important properties in physics: density and pressure. So, what's meaning by density? You have learned before that density is the ratio between the mass of any substance and its volume at constant temperature. So, density will be equal mass divided volume. Mass divided volume. And I want you to memorize this note very well. The temperature must be constant. If the temperature changes, the density will change. Density is a scalar quantity, of course. Scalar quantity means it has magnitude only. You have learned this information in last year. And measured by kilogram per cubic meter, or kilogram, per meter cube, or cubic meter. Either will be the same. The density is a constant physical quantity for the material. Just like the DNA in our bodies, the eye color, the skin color, all of these are DNA for our bodies and constant for our bodies. But there is factors or quantities. If I change these quantities, the density will change. Just like kind of matter, temperature, intermolecular spaces, and atomic weight. These four quantities are very important If one of these quantities changes, the density will change. Okay? I want to talk about temperature more specifically, please. If the temperature increases, the intermolecular spaces also will increase. Okay? As the kinetic energy of the molecules increases. If I increase the temperature of any matter, so the molecules will gain extra kinetic energy, therefore the kinetic energy will increase, and the intermolecular spaces will increase, therefore the density will decrease. So I can tell you that as temperature increases, density will decrease. And I cannot tell you that they are inversely proportional. Why? As if I told you x inversely proportional with y, so this means that if x increased to double, y will decrease to half. But if I told you x and y, if x increases, y decreases, I can tell you if x is doubled, y will decrease to quarter, for example. So they are not inversely proportional. But as we increase the temperature, the density will decrease. You must know, very important note, that the density of the solid, any solid, density of any solid is greater than density of any liquid, and the density of any liquid is greater than the density of any gas. Okay? Okay. We have another expression for the density, which is called relative density. Okay? Relative density. These are the rules, or these are the mathematical formula for the relative density. Relative density means the density of the substance relative to another density. The constant density we want to use it is water, so the relative density will be equal density of any substance over density of water, or mass of the substance or mass of water at constant volume, of course, or volume of water over volume of substance at constant mass, or the weight of substance or the weight of water at constant volume. You know that, of course, that the weight of any substance equal mass times g. G means acceleration due to gravity. Okay, and the measuring unit of weight, of course, is Newton. Okay, relative density is dimensionless. The relative density has no measuring unit, as it is the ratio between two similar physical quantities. Okay, if the relative density of the substance is greater than 1, so the substance might be a solid substance or a liquid, but of greater density than that of water. And if the relative density of a substance is smaller than 1, so the substance might be a gas substance or a liquid, but of smaller density than that of water. What is the value of the density of water? That's correct, 1 gram per centimeter cube, or 1000 kilogram per meter cube. And we're going to use the measuring unit of kilogram per meter cube, so the density of water will be constant at constant temperature. Okay, which will be equal 1000 kilogram per meter cube. Okay, that is for today. I'm hoping you are going to study this lecture very well and concentrate in the following lectures. Okay, thank you and goodbye.